Hey animal enthusiasts, it's Joel here, and today we're going to be talking about the endoskeleton of early vertebrates. Let's get into it. The clade we're going to be looking at first is Chondrichthyes. This is because this lineage is still extant and there are many species still in it today. The subclass Elasmobranchi includes sharks, skates, and rays, and these have a cartilaginous skeleton. We're going to be primarily focusing on the shark skeleton. The first structure is the condocranium, which houses the brain. This component is prominent in the shark skull, but is considerably lost in most other vertebrate skulls, where it has been replaced by dermal bone. Next is the splanchocranium. Here, there is a palato-quadrate, Meckel's cartilage, serrato-hyal, serrato-branchial, and if you look at it from the lateral side view, you can see the hyomandibular. As you go down the vertebral column, you will eventually reach the pelvic girdles. On the males, there are a pair of claspers, while on the females, there are not. Claspers are a synapomorphy for Chondrichthyes and represent the first form of internal fertilization. The evolution of Chondrichthyes eventually led to actinopterygii, also known as the ray-finned fishes. New synapomorphies include a lung, swim bladder, and endochondral bone. This means that as they develop, the cartilage is replaced by bone. Most of the fishes we know of today are included in the superclass actinopterygii. Observing the skull, we can see the tooth-bearing premaxilla and dentary. The maxilla has muscles attached to it so that it can act as a lever to protrude the upper jaw when the mouth is open. These fish also have a bony operculum, which is also found in chimeras in the Chondrichthyes clade. On the body cavity, there are two types of ribs. The longer ones are the ventral ribs and the shorter ones are the dorsal ribs. There are also haemal spines, which are caudal to the ribs and are ventral extending from the vertebra. The spines that are dorsal on the vertebra are called neural spines. This is where the dorsal nerve cord passes. The nerve cord is still dorsal to the notochord, like how it was with the Amphioxus and Ammocoete. The only difference for the perch is that the notochord has now become ossified to form the centra or centrum. This is how it is for most vertebrates. So yeah guys, that was my rundown of the physiologies from Chondrichthyes to actinopterygii. If you like this video, please make sure to like and subscribe, and I'll see you in the next video.